Hey, hello there. Today's Leetcoding challenge question is called +1. The question gives us a non-negative integer. It's represented as an array of its digits with the most significant digits towards the left. So it's thousands, hundreds, tens, and 0 to 9 in that order. The question asks us to do +1 to the integer in this kind of representation. So we want to do this +1 directly on the array of digits. We shouldn't do any kind of conversion between back and forth between the array of digits and the integer number. So we want to directly operate on this array. So there, just one note here: the integer does not contain any leading zero, so it's relatively clean in the input. So we don't have to deal with this. The way we solve it is pretty simple, straightforward. We just try to add one towards the last position. If it causes overflow, we will deal with that. If we can successfully add one, we just add one, modify the digit at that position, increment by one, and be done with it. If it causes overflow, that means the position has to have a value that's 9. We set this current digit to 0 and move to the left next position towards the left, and try to add 1 to that position instead. So in the extreme unlucky case, when the number is 999, we will set all 3 positions to 0, and we still have one that we need to carry over to the thousands position. So the way we do it is basically either append a single 1 towards the left, or we can set the first digit to 1 and append a 0 towards the end. So that's pretty much it. It's pretty simple. So let's solve this. So we're just gonna enumerate over all the digits from the right hand side towards left hand side. So we work from right to the left. We start with the last position, which is the length of the digits subtracted by 1. We want to decrease towards 0, and every time we decrease I by 1. So the position that we want to look at is going to be if the value here is less than 9, that means we can successfully add 1 without any overflow. So we just do that and return and break. Otherwise, it means that the current digits has to be a 9, so we set it to 0 and move on to the next iteration of the loop. If the full loop never break, that means the number is 999. We set all 3 positions already to 0. The thing we want to do is we could just set the first position to 1 and append another 0 towards the right hand side. So that's the code. It's pretty simple. So if we want to do some kind of arbitrary carry, initial carry other than the 1, we could just do that. Instead of having a hard code 1 here, we can just add the initial carry with the digits, and then do a div mod between this total and 10. Figure out what's the carry for the next position, and what's this position has to be changed to. It would work as well. So let's do this. It's a little bit more generic compared to the +1. So the carry initially is 1, and we're starting with the rightmost position. So the looping condition is that while we still have some carry that we need to add to the current position, and the I is actually a valid digit in this position, in the array representation for the number, what we do is to do this update. So we add the carry to the current digit and do a division and modular with 10, the modular is going to be assigned to this current digit, and we figure out the new carry that moves on to the next position. After that, we decrease decrement I by 1. So after this loop, if the carry is still not empty, it's still not 0, that means it's a similar story with 999 plus 1. We then just append this carry as a single digit toward the left. So this is the code that's a little bit more arbitrary. The initial carry is some arbitrary number instead of just 1. So let's try if it works. So some more test cases. 1, 9, 19, and maybe 999. It looks okay. Yeah. So the one on below is a little bit more generic. The bad thing about this is this append has to be linear time, because you have to copy the digits onto the new array, while in the append 0 here, you assign the first position to 1 and append a 0 towards the right hand side, and it's going to be this is a constant operation, so this is a linear time. But this solution is a little bit more generic, and the carry can be any kind of arbitrary digits between 0 to 9. So that's it for today.